Now, after understanding the pressure field equation for compressible fluid and incompressible fluid, in incompressible fluid we discuss in great detail. For compressible fluid we have just understood as per the level of our syllabus. Only thing we want to again emphasize here, that pressure in case of incompressible fluid is function of height only, and pressure is independent of shape and size of the container. It is dependent only on h, and h is a distance measured in perpendicular direction. In case of compressible fluid, we have to define the process. If process is isothermal process, then the pressure difference will be different. If process is a isentropic process, then temperature and pressure will be different, and we can develop the relationship for our atmospheric condition by assuming different type of process. And from 0 kilometer to 10 kilometer, we have a linear reduction in temperature, and that temperature lapse rate T is equal to T naught plus beta z. So, temperature lapse rate is known as beta. So, with this temperature lapse rate, temperature must reduce up to 10 kilometer. If it is not reducing with this much temperature, which I have just shown you, in that case the weather becomes unstable and it will lead to thunderstorm or pleasant movement of air. Right. Now, we are going to discuss how to measure pressure. So, there are several techniques or several devices which are used for measuring the pressure. In older days we had older techniques, and now we have very sophisticated equipments where the pressure is sensed and converted into some kind of electrical signal, and then it is fed. It may be manipulated in any manner and transmitted to large distance, and can be directly fed into computer, which will take care of controlling the pressure with the help of some suitable algorithm. Now, we shall start with some kind of definition of different type of pressures which are measured. We have generally these two pressure terms, absolute pressure and gauge pressure. Absolute pressure is a pressure which is measured with reference to perfect vacuum from 0 value, and gauge pressure is a pressure measured relative to local atmospheric pressure. Right. When pressure is measured with reference to local atmospheric pressure, generally we measure the pressure with reference to local atmospheric pressure. So, that is why we measure gauge pressure. So, to understand the difference between gauge pressure, absolute pressure and vacuum pressure, we have this figure. In this figure, we have a absolute 0 here, we have a absolute 0, and we have a pressure in y direction, and we have these 2 points, point number 1 and point number 2, right, these 2 points. And then here we have another horizontal line which is representing the local atmospheric pressure, right. This is the local atmospheric pressure. So, when we measure the pressure at point 1 with reference to local atmospheric pressure, then this is called gauge pressure. This pressure is called gauge pressure, when we are measuring the pressure available at point 1 with reference to local atmospheric pressure. When we are measuring the pressure at point 1 with reference to the absolute 0 or 0 vacuum, in that case this pressure starting from this point to this point is known as a absolute pressure, which is written here, absolute pressure at point 1. So, at point 1 we can measure pressure either with reference to the atmospheric. So, this one is known as a gauge pressure, and if we are measuring with reference to the vacuum, then it is known as a absolute pressure. Now, we have point 2. At point 2, if we measure with reference to absolute 0, this line, then this pressure is known as absolute pressure at point 2. So, for absolute pressure, if we measure with reference to absolute line, absolute 0, then we call it absolute pressure, whether it is 0.1, whether it is 0.2 or any other point. Now, if we measure this 0.2 pressure with reference to local atmospheric pressure, in that case we are going down with reference to local atmospheric pressure. So, this is known as gauge pressure, or many times it is known as a suction or vacuum pressure. It is known as suction or vacuum pressure at point 2. So, suction and vacuum pressures are gauge pressure below the atmospheric pressure for that atmospheric condition. Right. So, after understanding the difference between gauge pressure, vacuum pressure and absolute pressure,